Welcome all to Vectors Class 19. In this, we'll discuss how to solve the questions which are related to equilibrium of forces. Actually, this concept equilibrium we'll discuss in detail in Newton's laws of motion. But over here, there may be some questions which are related to vectors. They'll ask to find out what about the condition for equilibrium, or the object is in equilibrium, then what about the value of forces or number of forces, etc. So in the first part, there may be some question related to the number of forces required to keep an object in equilibrium. So just remember that if we are saying that an object is in equilibrium, it represents that the value of net force acting on that object is equal to 0. So if you are adding all the forces, then we should get the resultant should be equal to 0. So in the first part, we'll discuss number of forces required to keep an object at equilibrium. So we know that if there is an object and we are exerting a force of F on that object, then it is not possible to keep that object only by applying a single force. So we can say that with single force we cannot keep that object in equilibrium. So we know that the minimum number of forces required to keep an object in equilibrium is nothing but 2, and we know that for that purpose we should have two forces of same magnitude and they should move in opposite direction. So if you are having two forces of same magnitude in opposite direction, then the object can be in equilibrium. So the minimum number of force required is nothing but 2. Now if the magnitude of forces is not equal, then by using two forces we cannot keep the object in equilibrium. So if you are having a coplanar forces are in the same plane, same surface, but they are having different magnitude, then the minimum number of force required to keep an object in equilibrium is nothing but 3. So if you are having a force F1 is acting along this direction, and a force F2 is acting along this direction, and a force F3 is acting along this direction, and if you are adding this F1 vector plus F2 vector and you are getting the magnitude is equal to that of F3 and in the opposite direction, then the object can be in equilibrium. So over here you can say that the value of F1 vector plus F2 vector plus F3 vector should be equal to 0. That means the value of F1 vector should be equal to minus of F2 vector plus F3 vector. Same thing we can write with F2 also. F2 vector should be equal to minus of F1 vector plus F3 vector. That means while adding the other two forces, the result should be equal to the other force and the direction should be opposite. Then we can say that the system or that object can be in equilibrium. Now for this condition, these forces should be coplanar. Now if the forces are non-coplanar, so if you are considering a situation the forces are not on the same surface, if it is non-coplanar, then the minimum number of force required is nothing but 4. That means if you are adding F1 vector plus F2 vector plus F3 vector plus F4 vector, then we'll get the result will be equal to 0. So the minimum number of force required to keep an object is in equilibrium if the forces are non-coplanar is equal to 4. So once again just remember that if you are having two forces of same magnitude, the object can be in equilibrium. If you are having coplanar forces of different magnitude, then the minimum force required is 3. And if you are having non-coplanar forces, then the minimum force required is nothing but 4. Along with this, just remember this Lamy's theorem. So over here in a question, if it is given that the net force acting on an object is equal to 0 due to F1, F2 and F3. So we can use the concept of this Lamy's theorem. It states that if F1 plus F2 plus F3 is equal to 0, then the ratio of F1 divided by sine of its opposite angle, that is sine of alpha, will be equal to nothing but F2 divided by sine beta, and that will be equal to nothing but F3 divided by sine gamma. Or you can write another condition for this equilibrium is if many vectors form a closed n-sided polygon with all the sides in the same order, then also we can say that the resultant will be equal to a 0 vector. That means if you are just considering a vector, take it as F1 vector plus F2 vector plus F3 vector. So if you are adding these three vectors, then we can say that their resultant will be equal to 0. because it is coming to the final point. That's why we are writing if many vectors form a closed n-sided polygon, then also we can say that their f1 plus f2 plus f3 is equal to 0. Or you can write if we are having a vector along this direction, let's say f1, and another one take it as f2, another one take it as f3, and another one take it as f4. So if we are adding all these 4, then also we'll get the resultant is equal to 0. Now we can consider the next condition. If n equal forces act on a body such that each force makes an angle, that angle we can take it as 2 pi divided by n, means 360 by n, with the previous one, then form a closed polygon, so the resultant is also equal to 0. That means if you are taking the value of n is equal to 3, so we can write this 360 divided by 3 will get it as nothing but 120. So we are having a force acting along this direction and another force of same magnitude f making an angle 120. So we can say that this is angle is equal to 120 and with the previous one, and so this angle will be equal to 60, and again we are having another force of same magnitude f, and with respect to the previous one it is going to make an angle 120 degree. So over here we are getting an equilateral triangle, so again it is coming back to the initial point, so we can say that the value of net force is equal to 0. Same as like that, if you are going for n is equal to 4, so we'll get as 360 by 4 which is equal to 90 degree. So assume that we are having a force f, and with respect to that another force f is making an angle, let's say that is equal to 90 degree, and with respect to that another force is making an angle 90 degree, and with respect to this the fourth force is making an angle that is equal to 90 degree. So if you are adding these 4, we are getting like a sides of a square and it's coming back to this initial point, then we can say that the value of resultant or the value of net is equal to 0. Hope so that you understood this concept. If you are having any doubt, or if you like to interact with me on live classes, or if you want to write online test for JEE Mains, Advanced or Neet, or if you want to solve more number of questions to improve your performance, please let me know, and don't forget to like and subscribe this channel. Thank you.